Hi kiddos, this is Miss Stark with another video. This time we're going to be looking at dividing fractions page 2. So with this one, I'm going to be simplifying and I'm going to be making them into mixed numbers. So just to remind you, there are two ways to find, to simplify a answer for a fraction. You can either simplify it before you multiply by cross-reducing, or you can simplify after you multiply. I'm going to show both ways. Another thing is how to find the mixed number. So if you guys don't know, when the numerator or the top number is bigger than the bottom number, that is what we call an improper fraction. A mixed number makes that improper fraction into a proper one. And all you're doing is seeing how many times the denominator can go into the numerator, and then whatever's left over becomes your new numerator. So there's going to be a bunch of examples of that, and I'm going to show you. I'm also going to let you know the ones you're going to be doing on your own also need to be either simplified or turned into a mixed number. So I would like you guys to try your best when solving those. You get a point for attempting, and then a bonus point if you get it right. So let's get started. So the first thing I'm going to do is I'm going to zoom in to write my name. And for this one, after I write my name, I'm going to zoom in super close. And the reason why I zoom in super close is so that I can write even clearer and like neater, if that makes sense. So I zoom in to about 660%. I do have a pen, so it makes it a little bit easier for me. However, if you zoom in this close, it should be easy for you guys to write neatly too. And when you zoom out, it will look tinier, but when you're working on it, it looks huge. So our first step is to solve the problem. When we're dividing fractions, you just need to remember 3 words: keep, change, flip. We keep the first fraction as is, so 3/5. We change the division sign to multiplication, and we flip the second fraction. So the 7 will go on to top, and the 2 will go on the bottom. I'm going to write this twice. When you do this on your own, you're welcome to just use one way, whichever way works best for you or makes sense to you. So this top one, we're going to cross reduce. And this bottom one, we're going to reduce afterward. Basically reducing the answer. I prefer cross reducing just because it makes multiplication way easier in the long run. And who knows, we might not even need a cross reduce or reduce our answer. So in order to cross reduce or reduce our answer, what we have to do is find the greatest common factor that goes into both numbers. With cross reducing, it would be the numbers that are across from each other. So if you look at this multiplication sign, it's kind of like an arrow. Those are the ones that you're going to cross reduce. So 3 and 2, they're both considered prime numbers, which means only itself and 1 can be multiplied to make it. So nothing can reduce those. And the same goes with 5 and 7. So we're just left with 3 and 7, which is 1, and 5 times 2 is 10. And here we wouldn't cross reduce anyways, but we end up with the same one. Now here's the hard part. As you see here, this is what we call an improper fraction. Like I said, improper fractions are where the top number, the numerator, is bigger than the denominator, the bottom number. So here we need to figure out how many times can 10 go into 21. So what I like to do is do 21 divided by 10. And if you happen to have a calculator, you can use it. So on my calculator, I'm going to just type exactly what I wrote down, 21 divided by 10. And all I'm looking for is that number in front of the decimal. So just the 2. I don't care about anything behind it. I just care about the 2. That 2 tells me that that's going to be my whole number in my mixed number. So I'm going to have 2. Now, I need to figure out what 10 times 2 is. Luckily, that's pretty easy. Ten times 2 is 20. 21 minus 20 is 1. So 1 is my new numerator, and 10 is still my denominator. Now, if you are like a visual person, if we had circles, let's circle. We're going to split these circles into tenths. Or goes like this. See if I can just copy and paste those, because that's going to be hard to do multiple. Okay, so I have my 3, they look like oranges. But if I were to color 20 of them, so here's 1, 2, 3, 4, 5, 6, 7, 8, 12, 13, 14, 18, 20, 21. So as you see, 2 of them are filled up, and then the third one only has 1 filled. So that's how we get our 2 and 1/10. The reason why they're sliced the way they are is because that denominator 10 tells me there's 10 slices for a whole pizza, we'll say. So that is how I get 2 and 1/10, and there's a visual of how I get 2. So let's move to the next one. It is kind of time consuming to make those pictures, but I will make them for at least the first 3 problems if need be. So my next problem is 3/4 divided by 1/2. So remember, the top one is going to be cross reducing. Use a different color. Cross. Going to be answer reducing. Remember, you don't have to do both. You can just do one. So both of them are going to start off the same, with keeping the first number as it is, changing to multiplication, and flipping the second fraction. Keep, flip. So our next step, at least for cross reducing, is to see if any of them across from each other, which means the 3 and the 1 and the 2 and the 4, can be reduced. The 3 and the 1 can't. They are prime numbers. Plus, the only number that can go into 1 is 1, and that doesn't really reduce anything. So we look at 4 and 2. Well, 2 can go into both 4 and 2. 2 can go into 2 one time, and 2 can go into 4 2 times. So this gives us 3 times 1, which is 3, and 2 times 1. Okay, and we do the same thing here. We do 3 times 2, which equals 6, and 4 times 1, which equals. Here would be like, okay, is there a number that can go into both 6 and 4? There is, because they're both even numbers. We can say 2 can go in them. And you don't have to get the greatest one that goes into them. It just makes it easier and less repetitive. You can always stick with easy numbers like 2, 5, 3, stuff like that to make it easy. 2 can go into 6 3 times, and 2 can go into 4 2 times. And as you see, I basically ended up with the same numbers, I just reduced at different times. So here we're going to have, see how many times 3 can go into 2, or 2 can go into 3, which ends up being 1. And it goes the same with both of these. So then I'm like, okay, well, what is left over when I do that? Well, 3 minus 2, because 2 times 1 is 2, is 1. So my answer is 2 and 1/2. And if I were to draw my circle, and color 3 of these, you would see I end up with one whole circle colored in, and the second one only half of it colored. I have no idea why I put 2 and 1/2. That should be 1 and 1/2. Obviously, I'm not thinking straight. I was thinking of the 2 when you times them. I don't know why. But as you see, now our answers are the same. So next one is 5 divided by 3/5. So again, I'm going to use the 2 ways. After this one and the next one, I'm just going to stick with one way for each one. So again, the top one will be cross-reducing, the bottom will be reduce afterward. Okay, so if I cross-reduce here, 5 and 3, nothing can go into both of them besides 1. 8 and 5, nothing can go into both of them besides 1 and 5 and 1, basically. So we just multiply across for both of them. Okay, and we do the same steps that we did the last time, which is how many times can 24 go into 25? So we divide. And if I pull up my calculator and we do 25 divided by 4, you would see it's a huge, 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 huge number. But all we care about is what's in front of the decimal, which is just a 1. So 1. Now we do 24 times 1, which is 24, and we subtract that. 5. So that gives us 1 and 1/24. Unfortunately, I'm not going to draw this one just because that's a lot of slices I have to make. And it will take a lot of time to make it. But I'm sure from the other two, you can see that it matches up to the picture. As long as you don't do what I did with the last problem. Okay. Last one, I'm going to do both at the same time, which means I'm going to do cross-reducing and reduce answer. Remember, we change to multiplication, then we flip. For reduce answer, you multiply. For cross reduce, you see what we can reduce. Well, 5 and 1 we can't reduce because if I reduce by 1, there's nothing that can go both in. There's nothing that can go into both of them besides 1, and 1 doesn't change anything. 6 and 10, since they're both even, 2 can go into them. 2 can go into 6 3 times, and 2 can go into 10 5 times. And they can't be cross-reduced anymore. So now we're left with 5 times 5, which is 25, times 3. Now here's where these two can split off. We can reduce the answer right now, or we can wait until after we have made it into a proper fraction. I'm going to do the latter, which means I'm going to do it after I find the proper fraction. So here I'm going to see how many times 25 can go into, 3 can go into 25, which is 8. 25 minus 4, which is 8 times 3, 1. So it's going to be 8 1/3. Now here we're going to do the same thing, but with 50 and 6. So I have 50 divided by 6, which is also 8. And 50 and 6 times 8 is 48. That's 2. And my answer is 8 2/6. Well, 2 can go both into 6 and 2. 2 can go into 2 one time and into 6. Notice how I ended up with the same answer. If I reduced earlier by dividing both of these by 2, because 2 can go into both 50 and 6, I would have ended up with 25/3, and you would just do the same process I did up above. Now, I'm going to do 3 more rows, but for these ones, the first ones, I'm going to reduce the answer afterwards, and the last ones, I'm going to cross reduce. So all of these are going to be reducing the answer. Okay, so here I change the multiplication, and I flip. Then you just multiply across. 4/5. Nothing can go into 4 and 5, so that is my answer. Plus it's a proper fraction, so that's it. This one, I change the multiplication, and flip. 1 times 3 is 3. 2 times 2 is 4. Nothing can go into both 3 and 4. 3 is smaller than 4, so this is a proper fraction, and that's it. Next up is 6/7. Change it to multiplication, and 8. So we do 6 times 8, 8 over 7. Now 48 is bigger than 7, so I have to make it into a proper fraction. See how many times 7 can go into 8. Not 8, but 48, which means I'm going to pull up my calculator, do some math, divided by 7. I only care about this number up front of the decimal, which is a 6. Then I do 48 minus 6 times 7 is 42. That is 6. My answer is 6 6/7. There is nothing that can go into both 7 and 6, so that is my final answer. Okay, next up is 1/4. To multiplication, flip it. 1 times 2 is 2. 4 times 1 is 2 can go into both 2 and 4, so I'm going to divide both numbers by 2. 2 divided by 2 is 1. 4 divided by 2. Okay. So there wasn't a lot of reducing for this one. But let's see if there is any reducing for these. This is going to be cross reducing. Okay, again, keep our first fraction, multiply, flip the second one. Here there is some reduction we can do. Obviously, it's not going to be the 7 and the 1. Cannot reduce anything when the other number is 1. However, with 10 and 4, there is. 2, since they're both even, can go into both of them. 2 goes into 4 2 times. 7 times 2 is 14. 5 times 1 is 5. 14 is bigger than 5, so I have to see how many times 14 can go into 5. If I do 14 divided by 5, if I were to pull my calculator out and do 14 divided by 5, 2.8, I need to ignore the 0.8. All I care about is the 2. That's how many times 5 can go into 14. Then I subtract. 5 times 2 is 10. So my answer is going to be 2. That number is my whole number. 5 stays the same. And this is a 4. 4 and 5 can't reduce any further. Here, have 1/2. Change to multiplication. Put this to 11 over 6. Let's see. Nope, this is odd. That's even. Nope, that's a 1. Nope. So we're just going to multiply across. So 1 times 11 is 11. 2 times 6 is 12. The top number is smaller than the bottom number. This is a proper fraction, so we're going to leave it as is. Next step is 3/5 divided by 1/3. So we keep, change the multiplication, and we flip. So 3 and 1 cannot be cross-reduced because 1 is 1. Only 1 can go into it. 3 and 5, the only numbers that can go into both of those is 1, so we can't do anything there. So we're just going to multiply across. So we have 9 and 5. 5 is bigger than 9, so we do need to figure out how many times 5 can go into 9. 9 divided by 5, 1. 9 minus 5, 4. So we have 1 and 4. Okay, last one we'll do together. We have 1/4 times 8/3. So here we're going to cross reduce. 1 and 3 can't be reduced. 1 is the smallest it can be, and 1 doesn't change numbers anymore. So now we have 4 and 8. Well, I know for sure they're both even, so 2 can go into both of them. So 2 goes into 4 2 times, and 2 goes into 8 4 times. And I see there that 2 can go into them again. Times. And that should have been 1. So you can do something like that. So if you cross reduce, you can reduce multiple times until you get the smallest numbers possible. So here, this is a lot easier. Because now I have 1 times 2 is 2, and then I have 1 times 3 is 3. Super simple. I could have also gone straight to 4 and reduced it that way, but I still got the same answer in the long run. Now, if we're looking at these last problems on the bottom, they all need to be simplified in some way, either by cross-reducing or by turning it into a multiplication problem, not a multiplication problem, a mixed number, which is where you divide the bottom number into the top number by how many times, then subtracting them, and whatever you get is your new numerator. If you need to use pictures like I did, I will attach on this assignment when it's in Google Classroom a website that can give you fraction circles, kind of like what I made, or you can make your own like I did. Either way is fine. Remember, I do want you to at least attempt to reduce. So if you're unsure of reducing, I would reduce the answer, go with that way. If you're more comfortable with reducing in the multiplication problem, I would cross reduce. But if you're unsure, reduce the answer by multiplying first and then trying to reduce. Remember, you get a point. You get a couple of points. You get 1 point for the answer. You get 1 point for attempting to reduce the answer. And then you get a bonus point if you get it right. So you can get up to 8 bonus points because there's 8 problems left. If you have any questions, let me know. I hope this video has helped, and I can't wait to see you next time.